Hello students, how are you? I hope you all are doing well, right? Yes. Welcome to GLECTA. I'm your chemistry faculty and today's we are going to talk about analyzing pure substance and mixture, correct? So in the last class we were talking about pure substance and also we talked about mixtures. Other than mixtures, we talked about the kind of mixture do we have. Okay, so let's start today's topic. In this topic, we'll cover the changing state of matter. Also, we'll talk about what is melting point and boiling point of a substance. Then we will talk about analyzing pure substance and the mixture, in which we will talk how we can calculate or how we can find out that a substance is pure in nature or a mixture. And then we will turn to discuss the Kelvin and the Celsius. We'll try to convert the Kelvin temperature into Celsius and then we'll move towards the Celsius into Kelvin. So let's start. Yes. The changing in the state of matter. How we can change the state of matter? Actually, we can change the matter in two ways. The first one is by changing the temperature, whereas the second way by which we can change the matter, the state of a matter, is by changing the pressure. First, we will discuss how we can change the state of matter by the changing in temperature. Here we have two pictures. In the picture 1, you can see a beaker in which I have put some ice in it, correct? But after some time, if I raise the temperature, the particles of this ice will get separated, correct? And after some time, this ice will convert into liquid. This will convert into liquid. So how this happens? This actually happens that when we rise the temperature of a given substance, that substance will convert into the liquid. Therefore, the one way to change the state of matter is called the temperature. In the second figure, we can see that there is a water which is converting into steam. See, we can see easily how we can convert them into steam by raising the temperature. Here is we put a burner below this test tube. So if we keep on rising the temperature, the time will come when this liquid particle will get separated and then this liquid particles will convert into the gas state. So can you please draw the particle of matter? Can you please draw the particle of matter at solid state? This you have to draw for water. How the particle will be visible if the particles of water will be at solid state. And then you have to draw the particles of the liquid of water. And then later on you will have to draw the particles of gas, which means first when you are raising the temperature, the particles of liquid, when it is at solid state, these are very closely linked or they are very binded together. Once we have raising the temperature, these particles get separated and they turn their state into liquid. You can see in the particles the space is created. Due to this space, this they changes their state and that state is known as liquid state, and by which process we call them, by which process that solid is converting it into liquid, we call that process as melting. Correct? So what is melting? The process by which the solid particle or the solid matter convert themselves into the liquid matter, and by raising the temperature, that process is called melting. Whereas when you can keep rising the temperature, when you keep rising the temperature, these particles will further get detached and they will create a huge space between them. And when this happens, so this particle, the state of liquid will further convert themselves into the gas. And that is phenomena, the process that involves here, we call that phenomena as evaporation. Correct? So this is the one way in which we can change the state of matter. The next way is that, so we have understood that one is the melting. Melting is the process in which the substance convert into the another another state. For example, the solid convert itself into the liquid. In Let's talk about melting point. What is melting point? The melting point at which this is the temperature at which the substance changes into state from solid to the liquid at atmospheric temperature or atmospheric pressure. For example, if I am raising the temperature of ice, so the temperature at which these particles get convert or get detach or create a space between them, the temperature at which these particles create a space between them, they would be called as melting point. That temperature would be called as melting point. So when that temperature will arise, only then these particles will detach from themselves and they will create a huge space between them. And that temperature will be called as melting point. You understand what is melting point? Now let's talk about latent heat of fusion. It is quite related to the melting point. That's why I have included this point here. See what happens. If you keep rising the temperature of a solid substance, in a solid substance, you will see when this solid will convert into the liquid at one point, when the melting point reaches, you will see you have to give the same temperature for some time. For some time, you have to provide the same temperature. Why you have to provide the same temperature? When the particles of the solid convert themselves into the liquid, they need they need temperature, they need some energy to convert their particles into another state. When this happens, so the particles of the converting particles, like the liquid particle, have more energy and as compared to the solid particles which are in the solid state. So when these energy is converting from the solid to the liquid, that energy is called the latent heat of fusion, which means latent means the hidden heat. It is called hidden heat. In hidden heat means if the particles of the solid will acquire more and more energy, then only they will convert themselves into the liquid state. So they have to take more energy from the solid state. So if suppose I have the ice cube and I also have the liquid, that ice cube is converting into liquid. If some part of the ice is still remaining in the solid state, but some part of the liquid is converted into liquid, so the energy that have high at this time is in the liquid state, whereas the energy in the solid is, or this ice cube has less energy. Why this happens? Because this change in the state takes place, and this is called the latent heat. This has more heat. This is called latent heat. You understand what is latent heat? Okay, now let's talk about more. Let's discuss the definition. Latent heat of a fusion of a solid is defined as the amount of heat required to convert a unit mass of the substance from the solid state to the liquid state without changing the temperature. Means the temperature would be same at one point of time when the solid convert themselves into liquid. The the temperature of the liquid and the temperature of solid would be same, but the energy or the heat of liquid is much higher than the energy at the solid state. That heat that is absorbed by the liquid, that heat is called latent heat of fusion. Do you understand what is latent heat of fusion? Yes. Now let's talk about what is boiling point. See, when the substance or when the matter convert into the liquid, from solid to the liquid, and then if we keep rising the temperature, that liquid will further convert into the solid. But when the temperature at which this liquid will convert into this gas, that temperature would be called as boiling point. The melting point of a substance is the temperature at which, sorry, the definition is quite incorrect. You have to write here the boiling point of the substance is which at which the liquid boils to form vapor to the atmospheric pressure, atmospheric temperature. So what is the definition for the boiling point? We can say the boiling point of a substance is temperature at which a liquid boils to form vapor at atmospheric temperature. That is called boiling point. If we keep rising the temperature, the particles of the liquid will further detach, will further create some space between them, and these particles will convert their state, and that state would be called as boiling point. But there is a phenomena called the latent heat of vaporization. What is this? When you keep rising the temperature, you will see the temperature, the water at liquid state is, suppose for water is 100 degrees Celsius, the temperature at the vapor state would be 100-degree temperature. But these particles have more energy. They have more energy as compared to these water particles. Why? They are absorbing the temperature given by the external source. So they have more energy. But the temperature at the given point of time, we have same temperature. So why this vapor are consuming more energy as compared to the water? That is why they are hiding some heat. They are hiding some heat. That's why we have always observed that whenever we try to touch or whenever we get in contact with the vapor, we feel more we feel more burning sensation. Correct? Why we feel more burning sensation as compared to the boiling water? Just because the boiling water as compared to the vapor of vaporization of water has less energy. That's why we feel more sensation when we come in contact with the vapor. Correct? So have you ever seen that whenever your mother is cooking, but she will come in contact with that vapor that is being evaporated from the water, that vapor is much more, that vapor has much energy as compared to this water at the liquid state. So that is called the latent heat of vaporization. Correct? Now let's discuss the definition. What is latent heat of vaporization? The latent heat of vaporization is the heat consumed by the matters changing state from the fluid to the gas stage at a consistent temperature. The temperature would be the same, but the heat is comparatively high as compared to the liquid state. The gaseous heat would be high as compared to the liquid state. That heat which is being hidden in the vapor state is called the latent heat of vaporization. You understand? Yes. Now let's discuss the next one. Yes. As I have told you, we can change the matter by two ways. One is the by changing the temperature, or the another one is the by changing the pressure. So suppose if I have two three container. If not, I have only one container in which I am trying to, I have the particles, means I have gas. This container is filled with the gas, which means this container has gas particles in it, right? And the gas particle arrangement is like this, correct? Yes. So if I use the piston and I will put some pressure with the help of piston, what will happen? These particles would further compress themselves. These particles will be compressed, and one point of time these particles will come together and will come closer. And when this happens, the particles and the arrangement of the particles in this way, this is the arrangement of liquid state. So this is how we can change the state of matter using the pressure. With the help of pressure, if I keep increasing the pressure, the particles have to come closer, and then the particle will come closer. They will convert themselves in the liquid state. Do you have any example of like gases that we convert into the liquid state? Do you have an example? Okay, let me help you. Yes, we have example. If I can say that the liquefied petroleum gas that we use is the liquid is in the liquefied state. Why? It is the liquid state just because we are giving too much pressure to the gas, and that gas particles will come closer, and it will convert into the liquid state. If I will keep rising the pressure, this liquid state will further convert into the solid state like this. You can see the particles are very much closer, or very much like near to one another. They do not have any space between them. That's why these particles of the gas will further convert into the solid state. Okay, now I hope you are clear the way in which we can convert the state of matter. This is two ways. Don't think that we can convert the state of matter only with the help of rising the temperature or reducing the temperature. We can even convert the matter or the state of matter by using the pressure. Okay, now let's discuss how to analyze the substance, whether it is pure in nature or whether it is mixture. For that, we have to find out its fixed point, that is the melting point and the boiling point. For a mixture, the melting point and the boiling point may vary or will vary depending on the composition. But for a pure substance, the melting point and the boiling points are always fixed. For example, if I want to give you example called water. For example, the water has melting point is 0 degree, whereas the water has boiling point called 100 degree. If I will add some impurities or I will add some mixture in the water, the melting point would reduce. It may become -1 degree or -2 degree. And whereas the boiling point for the water may increase, it may come at 101 degree Celsius or 102 degrees Celsius or any other substance that I am adding to the like water. So it may vary depending on the substance that I am going to add in the water. So by for every pure substance we have fixed melting point and fixed boiling point. Okay. Yes. For the pure substance, there is a characteristic, it is a characteristic feature of the pure substance that at specific temperature they will melt or they will boil. For example, in the case of water, the melting point is 0. If the water is pure, the water will always melt at 0 degree temperature. If there is any impurity you will find in the water, the melting point would reduce. Means it may melt before 0 degree Celsius. By this method, you can easily analyze whether the substance or the is pure or if it is mixture. I hope you are understood. So the fixed point can be looked and identify the purity. So we can actually use the fixed points to identify the purity of a substance, whether it is mixed with anything or whether it is a pure. So how we can find out whether if we have an unknown sample. Suppose if I am giving an unknown sample to you, so what you can do actually? You can see that if the pure substance have melting point, this much melting point, we have already database or we have computed so many like pure substance of its melting point and the boiling point. If there is any impurity, then you can see any difference in the melting point and the boiling point would result in the addition of extra substance. So in the difference between the pure substance and the mixture can be distinguished if an unknown sample is given. We can easily identify whether the mixture or the pure substance is a mixture or it is a pure. The impurities will always tend to the melting point. It always lower the melting point, whereas it rises the boiling point. The size of the difference from the fixed point of a pure substance depend the amount of any impurity mixed with it. For example, like if you see, for example, if we have the water at 0 degree, but if I have the melting point is -1 degree, so I can say that the impurities in the water is much less. It is quite less. You can see it is quite less. Correct? So, but if the water melts at -2 degree or it melts at -3 degree Celsius, which means the impurities in the water are comparatively high, correct? So by the difference in the size of their fixed point, we can identify whether the mixture has the amount of impurities we can easily identify. We can easily calculate that the impurities is high or the impurities are less. You understand? Okay. Yes. I hope, and I want to give you more example of this impurity, and I want you to find some more examples of the pure substance of its melting point and the boiling point. Try to find out. This is your home assignment, or you can do some more research on it. Try to find out the melting point of gold, the melting point of aluminium, and the melting point of iron and its boiling point as well. Okay, if we can calculate or we can find out the melting point, if it is a pure substance, if it is pure in nature, then you have to find out its melting point and then its boiling point. Once you know its melting point, then you can easily answer if the melting point reduces, if the gold melting point reduces, then you can easily connect or you can easily answer that this gold has some impurities if the melting point lowers, correct? If the boiling point of the gold is comparatively higher than its actual boiling point, then you can easily identify that this gold has some impurities, correct? I hope you are now clear with this. Suppose if I am giving you another example of it, I have, if we have crude caffeine, the crude caffeine has some impurities mixed with it. Therefore, its melting point is 180 degree to 220 degrees Celsius. But when we refine these crude caffeine, the melting point would be increases. The pure caffeine is 234 to 237 degrees Celsius. It is the range of its melting point when it is at pure in nature. I hope you are more clear with this concept that how do we analyze the pure substance and its mixture. Okay, now let's move to the next one. See, as we have studied about the melting point, we have also learned about the boiling point. So we should know how to convert the formulas, how to convert the Kelvin and Celsius, how to convert the Celsius into Kelvin. So temperature, for calculating or for measuring the temperature, we have different units. That is called Celsius, one is called temperature, one is called Kelvin, and another one is called Fahrenheit. So we have three units to measure the temperature. Okay, but the most common that we use is Celsius. But these are also the units of temperature. For calculating or for converting the Celsius into the Kelvin, we have this formula. The K means Kelvin, or C means Celsius plus 273 decimal 5. This is the formula for converting the Celsius into the Kelvin. 0 degree Celsius means 273 point decimal 5 Kelvin. 0 degree Celsius is equal to 273 decimal 15 Kelvin. And 100 degree Celsius would be equal to 373 decimal 15 Kelvin. Okay. For example, if you have given Celsius, then you only have to do is just add the Celsius value plus 273, and then you will be able to convert it into the Kelvin. Similarly, if you have to convert the Celsius into the Kelvin, what you can do, write the value of Kelvin and subtract it from 273 dot or decimal 15. Let's do some questions based on it. See, convert 15 degrees Celsius into Kelvin. What is the formula for converting Celsius into Kelvin? The Kelvin is equal to Celsius plus 273 decimal 15. So what is the value of C? Is 15 dot 273 decimal 15. The answer would be 288 decimal 5 Kelvin. Correct? Are you understand? See, this is the formula that you have to learn. You have to learn by heart this. Once you will learn this, you will be able to answer all those questions when you have to convert the 15 degree or the Celsius into the Kelvin. This is the basic formula. Now let's do some more questions based on it. Yes, try to find out the 26 degree Celsius into Kelvin. What formula would you apply for this? The simple is that just write the degree Celsius, then add 273 decimal 15 Kelvin. Do not write K here, just write. Here you just write K. K means Kelvin. For this question, you can easily write 26 plus 273 decimal 15 and you will get your answer. And the remaining questions you have to solve from your home and try to find out these answers. Okay? Yes. Now let's move on. In this question, what you have to do, you have to convert the Celsius into Kelvin. In the previous question, what we were talking about, we were converting Celsius into Kelvin. Now here, you have to convert the Kelvin into Celsius. This you have to convert. So what is the value of K here? 300 degree Kelvin, correct? Yes. So let me put the values of K in the formula. Write the formula. The C would be equal to K minus 273.15. So the value of K is equal to 300 minus 273.15. The answer you will get for this question. Try to find out this would be equal to 26.85 degrees Celsius. This would be the answer. Yes? Any doubt? Do you have? No. Let's move on. Yes. Try to solve these questions. Convert 273 degree Kelvin into the Celsius. First, write the formula for this question. The C is equal to Kelvin minus 273.15. Then put the value of K and you will get your answer. Okay? Yes. Let's try to find out this question. Also, you have to do the same process for this one also. The K minus 273.15 and you will get your answer. Okay. The remaining questions you have to cover in your home. Okay. Yes. We have another unit of temperature, that is Fahrenheit. So for that you have to learn the formula for Fahrenheit. Formula to convert Fahrenheit into Celsius. So the formula for that is C means Celsius 5 by 9 times F, which is Fahrenheit, minus 32 degree. So the only thing that you have to do for this question, just put the value of F. The average body temperature of a house of cat is 101.5 degree. So what you have to do, the F is equal to 101.5. So just write the value of Fahrenheit in place of F and then subtract 101.5 and 32 and you will get 5 by 9 times what will you get? 69.5. And then what you have to do, you have to multiply 69.5 by times 5 divided by 9. Then you will get your answer 38.6 degrees Celsius. You understand? Yes. I hope you are clear with this. Just try to solve these two questions right now so that you can revise the concept. Okay? First step to solve this question is just write the formula for this, converting the Fahrenheit into the Celsius. What is that? 5 by 9 times Fahrenheit minus 32 degree. Just put the value of F all time and then subtract it from 32 and then divide and multiply by 5 by 9. Okay? Yes. Okay, next let's move to the next one. Yes. In this question, you have to change the Celsius into the Fahrenheit. In the previous question, what we were talking about, we were converting the Fahrenheit into the Celsius. Now we have to convert the Celsius into the Fahrenheit. Okay. The question is that ice or the frozen carbon dioxide changes at 78.5, it is minus 78.5 degrees Celsius at a normal atmospheric pressure. What is the temperature? What is this temperature at Fahrenheit? Okay, for the formula for converting Celsius into Fahrenheit is F would be equal to what is equal to 9 by 5. Then C, the C means the Celsius times C, then you have to subtract 32 from it, okay? So the F would be equal to 9 by 5. In this case, the C is equal to 78 decimal 5. So just put the value of C minus 78 decimal 5 minus 32. Then try to solve this part first and then subtract 32 from this. Okay, so how you are going to solve this? Just multiply minus 78 decimal 5 and then divide this value by 9 and you will get your answer. Okay, let me solve this one. 9 multiplied by the 9 times 78.5 would be equal to 706 decimal 5 divided by 5, then 32, and you will get your answer like minus 109 decimal 3 degree Fahrenheit after subtracting 32 from this value. First divide this number by 5, then whatever value you will get, just subtract 32 from it and then you will get your answer. Okay, any doubt? Okay, let's try to solve these two questions. The formula, the step 1 is equal to, right, F is equal to 9 by 5 times C minus 32. Put the value of C here and then solve this section first, then subtract 32. Okay? For the first question, what you can do, 9 by 5 times 25 minus 32, the value for 25, 5 will get divided by 25, you will get answer 5, then 9 times 5 will get 45, then 32, the answer would be, what will be the answer? Yes, sorry, it is 40. The calculation for 9 times 5 would be 40 and the answer would be 8 degree Fahrenheit. Okay. This is how you have to solve the remaining question and try to practice more so that you can easily calculate the conversion of the Celsius into Fahrenheit. Okay. Now we have to, this is quite typical, but if you are completed with the previous questions, you can easily solve this one. Okay, don't fear with it. Now you have to convert the Fahrenheit into the Kelvin. The formula for this one is equal to the K Fahrenheit into Kelvin. So You are writing K here and the F minus 32 times 5 by 9, then you have to add 273 decimal 15. This formula is for converting Celsius, and when you will convert this one into Celsius, you are just adding 273 decimal 15 and then it will convert into Kelvin. Correct? Yes. I hope you are generalizing this concept. This is the formula of converting the Fahrenheit into Celsius. Then that's why we are writing these here two formulas. One is this one and the another one is this one. Then you will calculate this question easily. Try to solve this question right now. Yes. Try to solve this one as well. Yes, let's do this question. If we have F is equal to 130 degree Fahrenheit, so what formula you are going to apply? The Kelvin is equal to 9 by 5 times, oh sorry, it's not 9 by 5, it is 5 by 9. By mistake, I am writing this one. Yes, it's 5 by 9 times F minus 32, then add 273 decimal 15. You will get your answer. 5 by 9, F would be equal to 130 minus 32 plus 273. Give me the value of these two values. Try to solve this. Yes, the 5 by 9 times 98, then add 273 decimal 15. First, try to multiply this number with the 5 and then divide 9. You will get your answers. Okay? Yes. If you have any questions related to the temperature conversion questions or any other topic that we have discussed till now, you may ask. Okay, let's complete this class and the remaining portion we will cover in the upcoming classes. Till now, stay connected. Bye bye. Thank you.